Hi everybody, and welcome to our listeners worldwide. I am Dorit Oren, Director of Product Marketing at Gilat Satellite Networks. As many of you know, Gilat is a leading global provider of products and services for satellite-based broadband communications. Gilat is in this business for over 25 years with over 1 million terminals shipped to more than 90 countries, and Gilat has over 20 sales offices throughout the world. Gilat is a strong player in many areas, but for this webinar I'd like to focus on the consumer broadband market worldwide. During 2014, multiple hubs and thousands of terminals were deployed at a diverse range of ISPs throughout Europe and Asia. As an example, we recently received a hub expansion order from SES Broadband Services. In today's webinar, we will focus on the untapped market of home broadband in underserved areas. For this purpose, Gilat has introduced an innovative solution which has led us to today's exciting webinar that we have titled Changing the Equation for Reliable Fixed Broadband. In today's webinar, I'm pleased to be hosting Yoram Ofri, Gilat's Director for Cellular Markets. First, a few procedural issues before we get started. If you would like to ask questions during the webinar, please type them into the chat box. At the end, we will take as many questions as time permits. If there are questions that we don't get to during this session, we will make sure to get back to you later. Don't be concerned in case you miss something. The webinar is being recorded and will be available on Gilat's website for further review soon after the webinar. Okay, so let's get started with the agenda. We will discuss the need for broadband and will review the current types of solutions and their challenges. From here, we will introduce Gilat's innovative solution that we have named SkyEdge2C Libra. We will go over the benefits of this solution for various stakeholders that include the MNOs, the ISPs, satellite service providers, and satellite TV providers. Yoram Ofri will then dive deeper into our solution. He will go through the solution components and discuss how it works. And he will also highlight Libra's features and benefits. And finally, I will summarize and take questions. Okay, let's turn to slide 3. Look at the pie chart in front of you representing internet connectivity in households worldwide. The left side of the pie chart clearly shows that in 2013, more than 50% of households did not have internet access. But the more remarkable point, in my opinion, is that 90% of these unconnected households, colored in orange, are in the developing world. In other words, this is a huge untapped market for internet access waiting to be connected. Let's look at how home broadband is being addressed today. The great majority of internet access from the home is delivered via fiber, XDSL, or cable modem. However, there is a market primarily in the developing world where there are other common solutions for bringing broadband to the home. They are solutions such as wireless radio, cellular, or satellite. Let's look briefly at the pros and cons of each. On slide 5, let's look first at wireless radio. See the schematic diagram taking WiMAX as an example. This solution has the following advantages. First, the CPE installation and activation is quick, and second, the cost is with relatively low capital expenditure. However, this solution is not easily scalable because of both the connection from the home to the base station, as well as the connection from the base station to the internet, i.e. the backhaul. For example, in rural areas, the WiMAX tower may be placed on a hill with the initial intention to serve, say, 700 homes. However, during the site survey, often line-of-sight issues come up where the visibility from the WiMAX base station to many of the homes simply does not exist, reducing, therefore, the number of sites to perhaps only 50. In other words, clearly a scalability issue. In addition, the point-to-point microwave link required for the backhaul from the base station to the internet often cannot be established easily. And this also contributes again to the scalability issue. Now on slide 6, another very relevant solution is the cellular network for delivering broadband to the home. See this schematic diagram. Here indeed we see huge coverage worldwide of the cellular network, which can be taken advantage of for broadband. Also, there is a great benefit of a consistent service provider who delivers services to multiple end-user environments, such as at work, at home, or even on the go. However, this great advantage of the cellular network to be used for broadband to the home is greatly compromised because of the following reasons. First, there is not enough available bandwidth to deliver broadband service adequately to all subscribers. And in some areas, the performance is on the verge of being unacceptable. The broadband speed is too slow and often inconsistent as you are further away from the cell. Often, slow data transfer speeds make internet use a frustrating proposition. When the mobile network operator cannot provide sufficient bandwidth or the end user is too far from the cell, the user experience is very poor. And of course, congested networks degrade the user experience and create customer dissatisfaction. And the third common solution in the developing world is the use of satellite for broadband to the home. See the schematic now on slide 7. Here we see an advantage of delivering high-performance broadband to the home with very quick deployment almost anywhere on the globe. This is an excellent solution. However, for some regions of the developing world, the VSAT cost is simply too high. So where does this take us? Gilat has conducted research and performed some studies to address this need. See now on slide 9. At Gilat, we questioned whether there is an innovative solution which will grow the underserved home broadband market. And indeed, we found that consumer broadband penetration is highly dependent on the VSAT CPE and installation prices. We have found this to be true in the developing regions, as you can see on the chart. The blue represents the CPE cost at X dollars, and the green represents X over 2, in other words, half the CPE cost. Look at areas on the chart like Eastern Europe, Latin America, Asia, Africa, and the Middle East. The green bar is more than double the blue bar. In these areas, we clearly see the predicted fast growth of the subscriber base that is directly correlated with a significant cost reduction of the CPE. I'd like to make a point that these regions are often cash-based economies where the prepaid model is the way business is done. This is contrary to the business model where the VSAT cost may be a part of the monthly payments. The prepaid model does not leave an option for the end user to spend hundreds of dollars in a one-time payment. And this directly connects to the high influence we are seeing of the cost of the terminal on buying habits. So what if we could take the best of both worlds? 1, cellular, and 2, satellite. First, let's look at the cellular solution. Recall that cellular coverage is ubiquitous. See this chart from ITE World Telecom showing that cellular coverage is already 96% worldwide, with more than 100 connections per 100 inhabitants. Quite amazing. But what is interesting for our discussion is that even in the developing world, mobile penetration is 89.4%. However, what about internet over the cellular network? The industry must find a way to address the often poor broadband performance to the home in those regions. Now let's look at the second solution we discussed, satellite. The satellite broadband solution easily provides the required performance anywhere most rapidly. However, the VSAT CPE cost is too expensive for some populations. So, to answer this need, we have taken the best of both worlds, the advantage of the cellular solution and the advantages of the satellite solution. How did we do this? Well, Gilat has built a hybrid terminal called SkyEdge2C Libra, and by doing this has slashed the end-user CPE costs dramatically. In designing Libra, we have capitalized on the asymmetrical nature of the home usage data traffic. Since consumers download much more than they upload to the internet, using satellite for the download and cellular for the upload is a clever solution. The Libra terminal will answer the performance needs for broadband at half the price of a two-way VSAT. This way we can give the underserved areas in the developing world broadband connectivity at an affordable price. This is why we have titled this webinar, Changing the Equation for Reliable Fixed Broadband. See here an illustration of two possible networks using this concept. Both diagrams use the Libra terminal at the home. Both use the satellite link for the download direction, and as such receive up to 20 megabits per second internet download speed. In the upload direction, we have two options shown in the diagrams. First, on the left, we see use of the existing cellular network. See the red circle on the left side diagram. And the second option on the right diagram, again circled in red, is the XDSL solution for upload. In both these examples, the upload speed is significantly slower than the download speed. However, more than sufficient for the home user, who of course is more interested in the download. In the download speed. Okay, so what's in it excuse me, just one second. So Gilat, has introduced an innovative hybrid solution, that includes the satellite and the cellular, to provide high-speed broadband access. Libra leverages existing networks and provides growth paths for MNOs, ISPs, satellite service providers, and DTH providers. Let's see what's in it for them and spell out the value proposition for each. On slide 14, let's start with the MNOs. Libra, the hybrid terminal, allows the MNOs to expand their reach by using their existing infrastructures. They can utilize their current 2.5G or 3G network for upload and offer broadband via satellite at high speeds of 20 megabits per second download without congesting their network. Note that this is true even in a 2.5G network with upload traffic at only tens of kilobits per second. This way, by offering end users a low-cost, high-performance VSAT CPE, the ARPU can be increased and customer loyalty sustained. Now moving to slide 15 for the ISPs or satellite service providers. What's the benefit to them? See the diagram of both options described earlier. The download channel is provided via satellite, and the upload channel may be via the cellular network or via XDSL. The current compromised network performance due to distance limitation can be boosted. The ISPs can increase revenue and gain customer loyalty with Libra. And I'd like to add also another value, that the installation of the one-way Libra VSAT is quick and easy. Now let's turn to slide 16 to address another market that can enjoy the Libra solution. This additional market is the satellite TV providers or direct home providers, also known as DTH. Here the current satellite infrastructure can be leveraged for an additional service. In other words, this solution gives the DTH providers the ability to participate with triple play. Look at the diagram where the DTH service is running side by side with the additional broadband service. Note that the same antenna and LNB can be used for broadband and DTH services. Clearly a win-win situation. Now I'd like to suggest taking a deeper look at Gilat's hybrid solutions, SkyEdge2C Libra. Yoram Ofri, Gilat Cellular Market Director, will now discuss the solution's components, features, and benefits. Just 1 minute.
Thank you, Dorit. So let's discuss the technical part, the more technical part. So Libra, the Libra terminal, it's easy to install. So we install a low-cost satellite reception terminal. This is not the normal, regular terminal that we use for two-way. This terminal includes an indoor unit, a relatively low-cost indoor unit that we call Libra, antenna, which is the same antenna they use in the direct-to-home DTH antennas for receiving TV programming, and LNB-F. So all this is very common in the television market, so it's really very low cost. So then we connect a standard cellular USB dongle to the indoor unit. We just plug it in. We get it and put a SIM inside the dongle, and then it makes it makes the Libra adhere and be part of the cellular network. And we upload traffic routed through the cellular network. Traffic is received at the satellite hub. I mean, it goes from the cellular network to the hub of the satellite hub of SkyEdge2C, and then it is handed over to the internet. So traffic goes from the home to through the cellular network, through the hub, to the internet, and then the response comes from the internet. Okay. So Libra solution main features. It's a carrier-grade hub. It's SkyEdge2C hub. It's integrated with the TotalIMS management system, which is a management system that we've developed specially for SCIGE 2C, when SCIGE 2C operates with multi-beam, KA, high throughput satellites, etc. So TotalIMS developed for this environment. We have a usage-based service definition system, meaning the one who gets 5 gigabits per second per month pays more than the one who pays for 2 gigabits per second, gigabyte per month, excuse me, gigabyte. We have improved user experience thanks to embedded TCP acceleration and HTTP acceleration. The outbound carrier, the signal from the hub to all the Libra at home or to the two-way VSATs that are used in the same network, this DVB-S2 is also operating with ACM, adaptive code and modulation, and this is considered the best in performance, the best modulation and adaptivity to climate changes. When there is rain, for example, then you cannot go at the maximum speed as the situation is with a clear sky, and then the throughput is going down a little bit, and even the end user will feel a little bit slower traffic, but this is very rare. And the normal situation is that you have very good throughput, etc. So we talked about the TotalIMS. We'll go a little bit deeper into it. Carrier grade management system. It's a centralized management for large multi-gateway networks. It doesn't have to be multiple gateway, but in the new era of what is called HTS and the use of new frequency, KA, it's not so new anymore. KA, very high frequency, but large of bandwidth. So there are multi-beam, similar to the cellular approach, and then you have multiple gateways, and the TotalIMS will control and show and demonstrate what's going on in the multiple gateway. So it supports hundreds of simultaneous web-based sessions, and it has standard northbound interface, what is called NBI, with the protocols SOAP and SNMP. So actually, mobile operator or an ISP can the one who has OSS, BSS, operation support system or business support system, can enjoy presenting and controlling the parameters of the VSATs, and the hub can control it from his own OSS and his own management system. This is thanks to the NBI, to the northbound interface. There's also accounting and quota management. We'll talk about it later. I just as an example, one who has 2 gigabytes per month and somebody else who has 5 gigabytes per month, they are treated differently, and the quota that they paid for is controlled. And of course you have alarms and statistics and reporting, and multiple ISP management. Multiple ISP is like what other people call a VNO, virtual network operator. So in the case of consumer, the virtual network operator is the multiple ISP. Which ISP is a VNO? Please go on, let's go ahead. So let's talk about the usage-based service, which we also call a FAP, which means a fairness user profile, a FAP. So it's integrated usage-based system integrated into the TotalIMS. It is working for prepaid and postpaid. Normally, when we talk about two-way VSATs and network in Europe, we'll talk about postpaid. And when we talk about people for example, in Africa or in the developing world, then we will talk about prepaid. Also, there's usage top-up. When the prepaid allocation is exhausted, then automatically the user will be routed to a walled garden where the only thing he can do is add money, put money through credit card or through whatever means is appropriate for that country. You can put money in and get some more gigabytes for that month or for next month or for any period of time that is chosen by the ISP. ISP controls what option. There are many options given in this usage-based system, and the selected option is the one that the ISPs will select. So there's priority services and, as we said, automatic redirection when the quota is exceeded. Let's go to the next slide, please. So we are now at slide 23, and we'll talk about the multi-tiered acceleration that enables high-speed web surfing and fast application response. So this includes TCP acceleration, which is common to the cases where the traffic, the TCP, is broadband, and at the same time there's a large round-trip delay. TCP that was developed like 30, 40 years ago didn't take into consideration such fat pipe together with a round-trip delay. So in order to avoid the limitation of the speed, to overcome limitation of the speed, you have to develop this TCP acceleration, which uses some other protocol in between the hub and the VSAT, and then you overcome the limitation, and it runs fast at speeds that are 20 megabits per second with the Libra, but with other VSATs, two-way VSATs of ours, we can run up to 100 megabits per second or more, so very high speed. Nobody will complain about speed. HTTP acceleration and optimization means that we do something called prefetch. We guess what will be the reaction to the HTTP GET that is coming over the uplink. And remember, the uplink is at relatively low speed, so we don't want to use too much the uplink. So once we get something at the uplink and we can guess what will be the next get or what will be the next request at the uplink, we automatically download it, prefetch it, and send it to the VSAT. So when there's the actual request coming in, it's already handled locally at the VSAT or at the Libra terminal without having to bring it or to ask for it over the satellite link or the cellular link. There's also DNS caching and compression that sometimes in some application can save 30% of the bandwidth or 50%, and some, but mostly in most cases it will be about 10 to 15%. Actually, because compression is already being done in the internet sites, and also video. If you want to keep the download speed of video and not reduce the quality, you have to you cannot compress the video anymore.
Thank you, Yoram Ofri, for this deep dive into how Libra works. I'd like to now summarize this webinar. As we saw in the beginning, the home broadband market in the developing world is a huge untapped market, and Gilat has changed the equation by providing a breakthrough solution that takes the best of the cellular broadband solution and the satellite broadband solution. Gilat has introduced a hybrid, low-cost, high-performing VSAT CPE. Gilat SkyEdge2C Libra is directed at the underserved market in the developing areas of the world with the mission of bringing broadband to the home. Now, there are many to gain from this. It's the MNOs, the ISPs, and DTH providers. And this Gilat's innovative solution has a few strong points that I'd like to leave you with. With Libra, they can provide high-performance broadband service to end users. With Libra, they can expand their network service by leveraging their existing infrastructures. And with Libra, they can provide a CPE VSAT at half the price. Thank you very much for attending. We have some time for questions. However, please don't hesitate to approach us after the webinar with additional questions and necessary clarifications. Please just give me now a minute. Okay, here's a question. Can Libra provide downlink performance of 20 megabits per second even if the uplink is limited to GSM 2.5G? Well, I can take this one. Yes, of course, we have tested this scenario, and the very slow uplink does not significantly affect the satellite downlink speed. Okay, here's another one, another question. Why do I need Libra if today mobile surfing or XDSL are offered at speeds of 30 megabits per second or even more? Yoram, can you please answer this question?
Okay, very good question. So the answer is really simple. We've addressed it in our slides. We say that we can do speeds of 20 megabits per second with the Libra. But of course, if you have very good performing 3G network and you are near the cell itself, then your speed up or speed down is good enough, and you can use your smartphone, or you can put a dongle into your laptop, and you don't need the Libra. That's when you are near the cell. This is your place of work, this is your place of home. It's strong, the signal is strong, and you have capacity and you have high speed. But unfortunately, many of the places that use the 3G, the HSPA, high-speed packet access, it's far like 10 kilometers, 15 kilometers from the cell, and then you just have a little bit of throughput. It's just the throughput is very low in the up direction and the down direction. And then you put the Libra to work, and now you have, at least in the down direction, you have very good speed, and you can surf the internet very fast. So it's not for every case, but it's for most cases in the rural areas. Same thing if you have 2G. With 2G, with GSM added by GPRS and Edge, the speed is limited to some tens of kilobits per second, or sometimes 100 or 150 kilobits per second. This is the speed up, and this is the speed down. Then you can use that with the Libra to achieve speeds of 20 megabits per second down. The speed up is still limited to the GPRS or Edge speed, but the speed down gives you surfing at very high speed, so you can download YouTube songs and movies and everything else.
Thank you, Yoram, for this comprehensive answer. And I have another question for you. Today, often video clips are uploaded to the internet. Libra doesn't address this issue of upload, does it? I think you sort of touched on that, but here, let me give the mic back to you again.
Okay, another very good question. Do we solve the speed limitation at the up direction? And the answer is no. So people may ask, how do I download my pictures from the trip that I did to Alaska? And the answer is, okay, it will just go slow. Actually, I can ask you, why do you care? I mean, instead of uploading your short clip movie or a 1-minute movie, instead of uploading it in 2 or 3 minutes, you upload it in 10 minutes. It's okay. It's fine. It's not that you expect response. It's not gaming. You don't have gaming there. It will not work for you. But the advantage of the Libra is in the high-speed downlink. That's where you get the high speed and you enjoy surfing the internet. And then you upload your movie. Well, it takes a little bit of time, like it was before with the 2G, with the Edge. But it works for you.
Yeah, thank you, Yoram. So to clarify, of course, when your primary businesses or concern is to download information quickly, Libra is the answer for you. And of course, if we're talking about a gaming application or an interactive kind of application, of course, then the low speed for the upload would be a problem. But as Yoram pointed out, often if you're just uploading information, there isn't someone waiting at that side for an instant upload. So that's why Libra can be a very good solution when the primary need is for, of course, the download speed. And one more question, is it possible to have the downlink from the satellite used by Libra as well as by a different Gilat two-way VSAT? So the answer here is, of course, yes. The downlink complies with DVB-S2, and as such, the wide downlink pipe serves multiple VSATs. They can be traditional two-way VSATs or the new Libra hybrid VSATs. As a matter of fact, the SkyH2C platform supports multiple applications concurrently in addition to broadband. So it's not only within the broadband world. You can be using the system for broadband in addition to other applications that we support, such as cellular backhaul, mobility, and a variety of enterprise applications. And to hear more about those, you should be listening to additional webinars that we will be giving. Or we all have already given and have been recorded, and you can be can be found on our website, www.gilat.com. So I'd like to conclude with that and urge you to keep in touch. I would like to thank Yoram Ofri, my colleague at Gilat, and of course I would like to thank you all for attending. As I mentioned, the webinar is being recorded and will be available shortly on our website. Enjoy the rest of your day, and this concludes the webinar for today. Thank you.